Let's take a look at this initial value problem. Y prime plus 2y is equal to f of t, where f of t is given by this piecewise definition. We can write this as factoring a t out, t times g of t, where g of t is equal to 1 if t is between 0 and 1 and 0 otherwise. And so the function starts at 1, and then it takes a step down of size 1 at time 1. And so the function f can be written as t minus t times u1 of t. And so that's a way of writing out the right-hand side. So to find the Laplace transform of this, we have to find the Laplace transform of the left and the right-hand side for this problem. So I get the Laplace transform of y prime plus 2y equals the Laplace transform of t. Now I'm going to rewrite this a bit as t minus 1 times u1 of t. Now the reason I do that is because when I find the Laplace transform, I have a t minus c and the step function at c aligned together. So that adds a plus 1, so I need to take a minus 1 to compensate. And so that is the right-hand side. Okay, so the Laplace transform of the left-hand side will be s times y of s minus y of 0 plus 2 times y of s. On the right-hand side, the Laplace transform of t is 1 over s squared. The Laplace transform of this, it's going to look like t, s squared again, except I have an e to the minus 1 times s on top because of the shift and the step function. And finally, the Laplace transform of the step function by itself is going to be e to the minus s times 1 over s. Okay, so on the left we have s plus 2 times y of s minus 3. Y of 0 is equal to 3 equals. On the right we have 1 over s squared minus e to the minus s over s squared minus e to the minus s times 1 over s. So solving for y over s, we'll bring the 3 over and then divide by s plus 2. Then we have plus 1 over s squared times s plus 2. Then we have here minus e to the minus s over s squared plus times s plus 2. Then minus e to the minus s over s times s plus 2. So I've got some inverse Laplace transforms to figure out. The inverse Laplace transform of this part is straightforward. That's just going to be an exponential function. Once I figure out the Laplace transform of the second term, I'll get the third term for free because there'll be a shift in a step function involved. So I need to figure this one out by partial fractions. Also, I'll need to figure out this one by partial fractions as well, ignoring the e to the minus s on top for the moment. Okay, so first things first, let's figure out the partial fraction decomposition for the last term, s over s plus 2. That's going to be a over s plus b over s plus 2. And so clearing out the denominator, we get that 1 is equal to a times s plus 2 plus b times s. Plugging in s equals 0, we get 1 is equal to 2 times a, so that a is equal to 1/2. If I plug in negative 2, I get 1 is equal to negative 2 times b, because this term goes away. So b is equal to negative 1/2. Okay, so there's my decomposition. That's equal to 1/2 over s minus 1/2 over s plus 2. Okay, so that's going to be the decomposition for this part. Okay, next we need to find the decomposition for this term, which will give me this term for free. So 2, 1 over s squared, s plus 2. The decomposition will have the form a over s plus b over s squared plus c over s plus 2. Okay, so clearing out the denominator, we get 1 is equal to a times s plus 2 plus b times s plus 2 plus c times s squared. Now I can certainly plug in a couple numbers here to make my life easier. So if I plug in 0, I'll get that 1 is equal to 2b. Everything else goes away. And so that means that b is equal to 1/2. The other thing that I can plug in to make my life easier is -2. That'll make these two go away. And I get 1 is equal to 4c, so that c is equal to 1/4. From this point, I could multiply out, but I only have one thing left, so let's just plug in some other number that's convenient. Let's plug in 1. I chose 1. I could have chosen literally anything, but I picked something that would be fairly straightforward to compute. 1 equals, if I plug in 1 here, I get 3a. If I plug 1 here, I get 3b. If I plug in c here, I get, or 1 here, I get c times 1. Okay, so 1 is equal to 3a plus 3/2 plus 1/4. Okay, so that gives me 7/4 over here. Bring that over. I get -3/4 is equal to 3a, so that a is equal to -1/4. And so my decomposition will be -1/4 over s plus 1/2 over s squared plus 1/4 over s plus 2. Okay, so with that in hand, let's take a look back at our decomposition here, y of s. So I have that y of s is equal to 3 over s plus 2. The decomposition of this part we just got done saying was -1/4 over s plus 1/2 over s squared plus 1/4 over s plus 2. Then I'm going to have basically the same thing again. I'll have minus e to the minus s, -1/4 over s, plus 1/2 over s squared, plus 1/4 over s plus 2. Same thing over again. And then for this last bit, I'll have minus e to the minus s. And the decomposition for this last term was 1/2 over s minus 1/2 over s plus 2. Okay, so let's figure out what y of t is. Okay, the inverse transform of this is going to be 3e to the minus 2t. The inverse transform of this part is going to be -1/4 plus 1/2 t plus 1/4 e to the minus 2t. Then minus the inverse transform of this. It's going to look an awful lot like this. The difference is that I'm multiplying by e to the minus s. So everywhere I see a t, I'm going to replace by t minus 1. So instead of a t, I now have t minus 1. In here, everywhere I see a t, I replace by t minus 1. And then that gets multiplied by the step function at time 1. Okay, lastly, there's minus here. The inverse transform of this is 1/2. The inverse transform of this is 1/2 e to the minus 2t. But because I'm multiplying by e to the minus s, the t gets replaced by t minus 1. And I multiply by the step function at 1. And so that is basically my answer. To make things a little bit simpler, what I can do is combine terms here. So I can combine the 3 and the 1/4 here, so that gives me 13/4 e to the minus 2t minus 1/4 plus 1/2 t. Also, I've got all these things minus u1 of t, so I can combine these things as best I can. So combining the thing in brackets and the thing in brackets here, I have minus 1/2 plus 1/2, that cancels. So I have 1/2 t minus 1/4. That's from this term and this term because the 1/2 times 1 and the 1/2 here cancel. Then I have negative 1/2 times its exponent, then plus a fourth times the same exponent, so minus 1/4 e to the negative 2t minus 1. Okay, now you'll probably notice that I could have combined these terms here as well. So for example, I could have combined the 1/2 s and the negative 1/4 s here. That would give me a 1/4 over s, which would have produced the negative 1/4 you see here. So things like that I could have done to simplify things. I didn't do that here just to try to make the parts here as transparent as possible, especially to make this line up with this. But there's certainly nothing wrong with first algebraically simplifying this as best we can, like combining this fraction and the 1/4 over s plus 2 fraction, factoring out e minus s on these two things. So that could have been done. I chose not to do that just so that I could have this line up exactly like this for the sake of the review.